This trajectory looks at the effect of grapevines and farm dams on suspended sediment yield in the Yarra catchment. So we've got three axes here. On the x-axis here we'll go suspended sediment yield. So this will be SS yield, and it will be in tonnes per annum. So T per annum per A. On this axis down here, we'll have two axes down here. We're going to have the vines, but we'll have the area of vine percentage area, we'll call it. So it's the percentage of the whole catchment, because we're going to have two axes on here. We want to make them non-dimensional. So you can either divide one divided by, or you can make it a percentage. In this case, I'll make it the percentage of the area, land area, percentage area. The next one we want is the percentage of area occupied by dams. So we'll call this one dam area. Or we'll actually call it the percentage. It's not the dam area. We'll call it the dam interception into C, which is the percentage of base flow percentage intercepted. So we'll call that a percentage here of the base flow. So the reason for that is we want to make it a nice comparable value. And so we can have the same thing on both axes there, up to 100% at the top here, of course. And then on the sides, this will be 100 up the top. And on the other side here will be tonnes. So we know that the average yield of sediment from agricultural catchment in Australia is about 5 to 15 tonnes per hectare per year. Okay, so that's the base number. So it's 5 to 10 tonnes per hectare. Now, with vines, that number probably goes up quite a bit. So if the area that's vine, it might go up to, say, 50 tonnes per hectare. Now, if the percentage of the area is, depending what the area is, we'll get an increase in yield. And so up here, we'll express this yield as something like just tonnes per hectare. Let's call it up to 50, because that could be what we get, 50 tonnes per hectare from the vines. Okay, I'll move that across over to here. Might be 50 up there, but what the point is, I'm not trying to get at absolute numbers, but just a range of values. So the first thing we want to get then is the area of vines, and the vines and the dams change the suspended sediment yield. So yield is our value, or the impact, and that goes into the Yarra and has an effect on water quality. So, sorry, that should be suspended sediment yield on this axis here. So let's have a look at what we're going to look at for our dam area. So let's start off with our vines. So remember the vines in 1880s. So we want 1880s back here. I'll just mark some axes here. So this one is 1880s. Back there, we're going to have another one which will be about there. We're going to have another area here which will be what? 1980s, let's say, because that's when the vines started to come back in again, 1980. That'll do about here, and then we've got the future. So all we want is a line for the area of vines. Now, in the 1880s, remember, they went up to the very highest percentage area. Let's say it was 50% up here, and then they fell off quite quickly towards the 1920s. They hit the 1980s. They came back up to their original area, and then they went into here, and they probably might go up a little bit like so into the future. So let's just mark where we're on we're here in the future. So that's 2020. The next thing you want to know is the area of dams. So let's plot that. Now, that they didn't really have that many dams back in the 1880s, but from the 1980s they started to do them. They often build the dams before the vines so they can get them going. They'll go up here, and then they'll reach some limit, which they've probably reached about now, and they'll continue on. Now, what can happen here is for our suspended sediment yield, we're looking at red, and so the yield, the background yield in 1880 was down here, and then as the vines were planted, the yield would have gone up rapidly with some sort of lag. And then as the vines came off, it would have come down, but again with a lag. It wouldn't have stopped straight away because they went to grazing, and it wouldn't have come back to normal because grazing still produces sediment. Then the dams are built, and they sort of trap sediment, so our suspended yield would have declined at that time. Then the vines would have been planted. Then there would have been an initial spike because bare vines produce much more sediment than mature vines, and then they would have come off like so up to the present. And then in the present, what would we do to reduce the yield further? We might put all sorts of treatment in. We might put bigger dams, and we could potentially reduce that yield even further back to there. So that's an example of a vine trajectory.